All right. Hello again, everybody. I didn't know this was going to be a deep dive.
Third or second?
This is my third. Yeah.
Okay.
Yeah. Third time's a charm. I didn't know this was going to be a deep dive. We'll start with a shallow dive, maybe, and see where we get. Let's just start off by having everybody introduce themselves. We know Guy, of course, co-founder of Fhenix. And how about our other
I
panelists?
am Rookie from Privasea. Yeah, I specialized in privacy preserving technologies, especially fully homomorphic encryption. And our privacy is concentrated on the cutting-edge intersection of FHE and artificial intelligence. So if you are interested about us, you can go to tomorrow's Inco's FHE Summit or Zama's co-FHE, and we will introduce a lot of our privacy and FHE and also our face recognition applications. Yeah, thank you.
Hi, everyone. My name is Remy. I'm the founder of Inco. What we're building is what we call the universal confidential computing layer of Web3. So the problem we're solving is that all the blockchains today are completely transparent. And so what we want to enable is this idea of private state and also private compute.
Great to meet you both. Rookie, I think we're competing with who has the most outdated headshot. So you look quite younger in that photo, and so do I. I think we need to get those updated soon.
But I'm a little bit older than the picture, yeah, right?
New glasses.
But it's great to meet you guys. And look, I want to take this opportunity as people who are like working and building in this space. Like, when did you first find out about FHE? And then how did you make that decision that this is something that you want to spend your time and energy, right, which is your most precious resource, building in? Like, was there like an aha moment for you? Or like, this is important. I want to work on this.
Yeah, I can start. So I've been in space since 2017. The first time I heard about FHE was probably the Zero Knowledge podcast from Anna. I think it might have been the interview with Sunscreen. And then the first time I got to play with FHE was with the Zamatech last year. And so I was actually building very deeply into the ZK space. And when I came across FHE, it was very obvious to me that it was solving a problem that hasn't been solved in the past in a different way compared to ZK. And for me, as you know, coming from a builder background, I think it was very obvious to me that having encrypted states on chain and to be composable would be a game changer for enabling sort of new use cases in the space. And so from that perspective, to me, it felt early, but also sort of the right time to get started. And then, at that point, what I first wanted to build was FHE dApps, but there weren't enough infrastructure. So ultimately decided to commit to building infra, which was sort of related to my previous background as well. I was building an infra on Polkadot. We built one of the largest DeFi protocol with over 500 million TVL at the peak. Building infra to me was sort of like the prerequisite for more developers to enable applications and things like that. Yeah.
That makes a lot of sense. So you come from like an application developer background, and then, we need this infrastructure to have confidentiality. I'll work on that.
I would say a mix of both. I definitely done plenty of application building. So this is where it was very obvious to me that from a development perspective, the form factor that FHE enables is essentially the concept of private state within Solidity. It is a 10x improvement to something that's more off-chain based, or where you have to learn more complex tooling that's ZK based, right? New languages, new toolings. So that, from a builder perspective, to me was a clear improvement. And then from a protocol perspective, builder, yeah. So we were building on Polkadot before. Today we're using Cosmos, very similar, a lot of overlaps. Yeah.
How about you, Rookie?
Yeah, I'm majoring in fully homomorphic encryption, so I first encountered FHE during my graduate lessons and graduate class in. I think
they have classes on FHE.
Yeah, we have classes on FHE. Yeah, and I think FHE, the conception of computation on encrypted data is very powerful, and the functionality is it's appealing. So I decided to work on FHE just because this. And another reason is that I think FHE developed rapidly, and in the past 5 years, maybe another technologies like some data mining technologies like machine learning also developed rapidly. So it make data to be the new oil of and it make privacy a really I think a really pinpoint. Yeah, we should address to So FHE is valuable now. Yeah.
And Guy, I mean, for such a cutting edge new technology, you've been in the space for quite a long time. Do you want to share just a little bit about your background?
It's actually kind of a funny story because my first relationship with FHE started in 2017. I worked at Intel and I led Intel's trusted execution environment ecosystem development. And one of the conferences, I met Shafi Goldwasser. Some of you may have heard of her. She won the Turing Award, like a super brilliant mathematician. And she gave a talk about FHE. And that was like, what is that? Like, it's the first time you hear that you can compute on data and the result is encrypted, and it's like it sounds like magic, and it sounds like too slow. And she showed numbers, and he showed that it's actually feasible. But I was on the camp of TEs. I used to say, oh yeah, it's mathematics. It's interesting, but it's never going to happen. And then I took a leave of absence from that space for a couple of years. And then in 2022, I got back and I led Intel's fully homomorphic encryption team. Intel's building a hardware acceleration for FHE. And I got a chance to scan the entire market. So I talked to federal entities and cloud service providers and financial institutes. And all of them showed interest in FHE because people like to trust cryptography. I'm a strong believer that TEs are great, but specifically for the crypto space, I would say there are many applications that just this industry would rather to have cryptography and mathematics over trusted execution environment. And once I figured out it was like an easy decision, we have a great cryptography solution, we have a problem which we believe is the next problem to tackle in the blockchain space, which is lack of data confidentiality. It's a perfect match, and that's how we started actually Fhenix.
Just quickly from my part, like when I first learned about FHE, like I had a misunderstanding about how other types of encryption worked actually. And when I learned what FHE, it allows computation over encrypted data, I'm like, oh, well, that's kind of how I assumed all encryption was, but that's actually not the case. I think it should be the case. Which brings me to my next question. I'd love to hear from the panel, like, how do you guys feel about the overall state of like confidentiality on Ethereum? Like, we've ended up with this kind of totally translucent public blockchain. It seems, at least from my perspective, that there might be sort of a change occurring. Like, I think the privacy narrative is maybe gaining some traction, but what do you guys think?
Yeah, maybe I can start. So, obviously this confidentiality problem is now solved in crypto space. There has been various attempts using different solutions that are MPC-based, TE-based, ZK-based. I think FHE here offers a kind of like a novel category here in a new attempt to solve this problem. Where I see FHE really shine is really around composability. If you compare something, compared to something that's more ZK-based, ZK, I would argue, has more privacy because the unencrypted data typically never leaves the client. It's encrypted off-chain. But what you lose is recomposability. With something that's more FHE-based, what you lose is you have a little bit less privacy because your decryption is MPC-based, but you have a lot more composability. So my perspective on this for, I'll say, Ethereum or any EVM blockchains is if you look around all the use cases we have today, whether it's DeFi, gaming, DIDs, these are all multiplayer applications. So you need to interact with each other's states in a permissionless manner, ideally. So this is where I think FHE does really shine in terms of, if I want to take a flash loan and use it for a private AMM, that composability really plays a huge role, right? If you want to do private voting, what you typically do is you get let's say the amount of tokens, unit tokens you hold. So you need composability to read your balance and then cast a vote, right? So this is where, FHE, the form factor of FHE, because you're encrypting data, and that data can be stored on the blockchain, very similar to how you store a normal EVM state. A lot of the form factor of storing the data, which is a private state, and then computing on top of it, just makes it very intuitive. And yeah, so obviously there are trade-offs, right? Other trade-offs around the short-term throughput that we have with FHE, but that will also be resolved over hardware. But yeah, I'll take a pause at that, and yeah.
Thank you. I think maybe in the early time of blockchain, privacy is not really a pain point because it wasn't a barrier to making money, right? So our keyword is consensus, and our keyword is decentralized. But nowadays, as privacy concerns grows, users want to control over their data and they demand confidentiality. So our translate blockchains like Inco, like Privasea, our translate blockchains can offer users can transfer their data or even process their data or share their data or just make transaction privately, and then they can also still benefiting from the decentralized nature of blockchain. So I think it's maybe a promising future, and it will there will be a lot of privacy-centric adoptions or applications, I think. Yeah.
Yeah. I would say we need to split it into two different domains. One is, do we believe that confidentiality is missing? Yes, blockchain brings a promise that enables users to control their data. But the reality is that, yeah, you can control the data, but everybody can see your data. So do you really control your data? By introducing core encryption capabilities, you actually give users the ability to control who can see their data. And that goes beyond just protecting the user's privacy. It unlocks use cases and applications that wasn't feasible before. Every second person I've been talking here at the conference, the first question was, okay, what's the use case? And when you start giving examples, like, can you transfer salaries on chain? Clearly not. Can you do confidential transactions when you don't have encryptions? Clearly not. And it all sounds very, very logical. So for me, this is an evolution. This industry is maturing. We heard Ed earlier from Arbitrum talking about resiliency. We know that the costs are going down. We know that scalability is being solved. So just putting it, the underlying infrastructure for encryption is really, for me, the next problem to tackle. The second question is about, okay, so who's going to win? Well, like, which technology is the best? Is it ZK? Is it MPC? Is it TE? It's not about like one technology. It's going to be a mix of them. We're going to see different use cases using different technologies. We're all here because we strongly believe in FHE. We think that FHE is the end game, but there's going to be space for others. So at least for now, we may have a different conversation 2 years from now. But for now, let's just get the use cases out there. Let's get the applications start to use encryption, and then we'll start dealing with like who's the best out of the different technologies.
So, go ahead.
Oh, I want to, I agree with the guy. And, a lot of people think what we do is just privacy, but there are just so many use cases outside of privacy, right? Like simple card games have nothing to do with privacy, blind auction. And I guess like what I like to explain to people is that in Web 2, when you build something like, let's say, eBay, you have this private server where people submit their bids, and then they selectively not reveal people's bids, right? That concept doesn't exist in Web 3 because everything is transparent. And you cannot do private states in a blockchain because everyone can read these states, right? The only solution for that is encryption. So by encrypting a state, you recreate this concept of private state you already have in Web 2, and with FHE, you can compute on top of it. So now you can build more complex logic. So what we're really doing here is bringing more Web 2-like experiences to Web 3, and that goes beyond privacy, right? Yeah.
So a couple of you mentioned use cases. Speaking of use cases, I would love to ask the panel about another very trending topic right now, which is AI. A lot of people talk about the intersection of blockchain and AI. I don't think it's necessarily obvious what that is. So I would love to hear your take, and specifically as it relates to FHE, where do you see these two things intersecting? How does FHE maybe facilitate or enable new use cases with AI? Any thoughts there?
Yeah, I think AI indeed is now changing our life. For example, for my business trip to Brazil, I planned it by ChatGPT. However, I think ChatGPT is deal with a lot of information of myself, like my schedule, like my hotel information, and some other personal sensitive data. So that's why I think artificial intelligence and fully homomorphic encryption, they share common grounds because they also deal with sensitive data. Our FHE can enable secure AI applications. For example, our face recognition applications, we can encrypt users' face data and then give to the server. The server make a check and then give back the result to the client. And then the client decrypt it locally. So at all the time, the server cannot deal with your really rough information. So I think FHE give us a path to this bright future. Like imagine the ChatGPT can plan your trip, or just it can we can train the models on encrypted data without touching any your rough information. Yeah, that's the application, I think.
Yeah, I've been using this phrase like the AI age. I think we're in the AI age, right? Like these technologies are going to continue to be used. They're going to become more and more prevalent, and I definitely see a place for encryption and FHE there. I mean, these queries should be confidential, I think, by default.
I would say we're at the start of the AI age, because for me, what happened in the last couple of months was there was a lot of money at VCs, and that money was spent on AI projects with blockchain because it makes sense. There are some very logical applications, like what Privasea are building. Some of it are still yet to be proven. But the core underlying AI story is about data. You need to get the right data for training. How do you get the right data for training? Today, training is done on public data. How can you take data which is not public and drive it for AI training? That part, like, users won't give their data for training unless it's encrypted. So that's like one way to explore the discussion. The second part is the fact that we lack a lot of user experience in Web3. It's hard to onboard users, and I think there is some narrative that potentially with AI we'll be able to also mitigate that part. We'll be able to generate much more developers because it's easier to write smart contracts. We'll be able to fix the onboarding experience. So there are a lot of intersection points, but it's really very early. I think a lot of it is still very hyped, and I'm pretty sure something will come out of it. Which one will win? We're still on the fence.
Yeah, definitely. I do think we're early. I mean, there are obvious problems, right? Enterprises, they wanted to use ChatGPT. They're worried that the data you fit in can be sent to OpenAI. If you want to train, let's say, healthcare data, these things typically have a lot of regulations around it. So definitely, I think FHE has a very strong place in solving these problems. It is a little bit hard for mass production today. Today, you can do simple inferences over FHE. But if you have encrypted matrices, it's actually going to be a lot more difficult. Or if you want to do FHE machine learning training, it's also going to be inefficient. So we see people like NVIDIA offering kind of like TE-based solutions for now. But we all believe that FHE, something that's more cryptography-based, will be the end solution. And the way you want to sequence or like the use cases also basically would have to be based on like what's feasible today, what makes sense, and then have a transition period.
I think it is very important, though, like as we saw with Apple's recent announcement, right? Like these big companies are thinking about it. Like it is an integral part of the AI age. And then we could get into like data sovereignty and data ownership. I think we're out of time. We're going to have to leave that for another day. But thank you guys so much.
Thanks a lot.
Thank you.
Thank you.